Okay, this is the second paper in the session. We've got Kate Hapgood from Capgemini and Neil Hunter from Zero Avia with their presentation on disruptive system engineering. So, thank you.
Okay, thank you. So, this Dr. Kate Hapgood was a respected doctor of paleontology before moving into software systems engineering, spending 20 years at Praxis, come Altran, come Capgemini, where you're currently system architect for defense, aerospace, and rail projects.
This is Neil Hunter, so previously a respected mechanical engineer for 7 years before again joining Altran, come Capgemini Engineering as a systems engineer. And then more recently moving over to Zero Avia, where he's the lead systems engineer for exciting projects looking at developing carbon-free aviation. And we want to talk to you this morning about the need for systems engineering to sometimes be disruptive.
I know it's definitely a theme for this session, yes. It would seem. So if we kind of go back to fundamentals first, so what is system engineering? Why are we here? So system engineering, we're doing this to deliver a strategic goal. We do it so we can deliver systems that work. That is, systems that will integrate, systems that can be used in the real world, and systems that meet a need within that real world. And of course, to do this, we plan our systems engineering activities, we plan our system engineering work, we follow a path towards our goal in alignment with the project plan that we've been set out on. One of our purposes as system engineers is to discover problems and discover them early. Because if we don't discover them early, they become more difficult and costly to fix the later we get within the project. And sometimes, in order to correct those, we actually have to do a little bit more. We maybe have to change our architecture, change our solution, change our direction to ensure that the project can actually meet its goal if the goal's changing as we go. This is quite disruptive to the project, but ultimately necessary in order for the project to deliver what it needs to deliver.
So we've got a bit of a quandary here. We systems engineers, we want to find problems to improve the outcome in order to improve the outcome of the project. But this slows us down and disrupts. And it's nice to think that this is a solved problem. It's such a ubiquitous tension between the strategic goal and the tactical needs to make stable progress. But it seems not. I mean, it's research that Bruce Elliott has done has shown us that large, complex enterprises find it difficult to respond to change. They take too long to respond to change, creating a wasteful change latency. And we see other patterns in this tension too. For example, have you ever experienced a project that set off to a clear target, then discovered a need for change, responded, but without fully understanding the change in the whole, without understanding the compromises involved in that, and so responded to each new piece of information and each new opinion following a wandering path to its ultimate goal, following an inefficient path to its ultimate goal? Or, different pattern, a project that struggled to gain momentum, it lacks a clear purpose and drive, but instead is relying on fairly heavyweight processes designed to eliminate risk, but these cause the project to dither, they cause a general sort of timorousness in the face of uncertainty. The project's unable to gain momentum and may be overtaken by events. Or, this is the final example, I promise, a project that sets off at speed, makes good progress, but hasn't understood the target. When the target is properly fully understood, the problem space is properly fully understood, difficult changes emerge as the project needs to retrofit work completed, and that they don't want to throw away the sunk cost fallacy to the newly fully understood the newly fully understood target. The project, like coddywamples its way, and it becomes inefficient. So with an initial impression of speed, but in experiencing those late-breaking architectural problems that slow it right down and inefficient.
Okay, so for systems engineering to deliver what it promises, it must be legitimate to discover and make early corrections, and that's what we're saying. In this case, it means to be disruptive. And on the face of it, being disruptive in a constructive way is relatively straightforward. We start fundamentally with understanding what is the real world problem that our project's aiming to deliver. So not what we as individuals or teams are trying to get out of it, not what our companies are trying to get out of it, but what is the objective that system is delivering in the real world. And so then when we really understand and appreciate that, we can understand if our project is still moving towards that goal, or if it's veered away or it's stopped progressing in some way towards it. And in that context, if it is veering away towards it, then we decide what do we do about it? What needs to change about the project in order to correct that. And then finally, we actually have to implement it and not just talk about it or think about it or discuss it, debate it in endless meetings, but actually act, implement something that will correct the course of the project towards the goal and then restabilize the project once that course correction has been applied.
So we compared experiences across the life cycle in different types of engineering and identified 3 tensions that we've observed block a project from making that change and responding efficiently. So the first being how we as individuals and organisations avoid problem areas and conflicts because they slow us down. The second, our desire to get the right solution and be the originators of the right solution and to get it right first time. And then finally, the games we unintentionally create when we create that well-defined process and we start to measure progress against process rather than progress towards a goal in the real world.
So if we look at each of those 3 things in turn in a bit more detail. So first of all, this idea of we focus on areas of agreement, we focus on areas of conflict. And we can kind of think of this as a bit of a tug of war. Forces pulling either side, creating this tension. And on the one hand, we've got this focusing on areas of agreement, looking at what's the next steps, what can we progress now, what can we get to quickly within the project. Realizing that problems, frankly, slow us down, and we kind of tend to avoid that, whether that's consciously or not. We can kind of skip around problems in order to maintain our sense of progress. And so we're following that planned route. We're hitting our milestones, we're hitting our delivery commitments. And these are really driven by lots of project forces, project pressures, business commitments, those sorts of things really drive us towards this kind of mindset and this focus. But we need to remember that we need to pull the other way as well. We need to focus on what are the real world outcomes. Where are there conflicts between our stakeholders, between our team and our stakeholders? What do we not understand about what our stakeholders' needs and objectives are in the real world? What do we not know about the adoption or new and novel technology that we're applying? What do we not know about our customers and how they're going to use it? What are those problems that we need to identify?
So again, to meet our strategic goal, we want to focus on problems. They want that to be our primary focus. But if we do that indiscriminately, then we create a different problem. We can slow the project down, stop it gaining momentum, and create problems that way. So we need to be able to, at the same time as focus on problems, be able to identify those problems that really matter right now in the project life cycle and differentiate and recognise that not all problems are the same value to us at each point in a project's life. And we can do that. We can do that fairly systematically. We can look at how well we understand the problem, how well we understand whether there are conflicts and the potential range of solutions. We can look at how well we can contain the impact of resolving this problem now or resolving it later. And we can look at how much, what does it take to solve this problem at this point in time? Is this an efficient time to solve the problem? For example, we have a blue problem on my matrix up here. This is a well-understood problem where we're confident we can contain the impact. Maybe it just affects one component in our system. This is unlikely to be our highest priority problem. It's not going to be an issue. The project can tolerate carrying this problem and not solving it right now. It's not going to have a huge impact. And we're confident of that because we understand the problem. Whereas a problem where we don't really fully understand, so maybe there's a use case or a user that we haven't properly understood, but their interface is in a particular area of the system. We can design our system to compartmentalize this problem so that the impact can be tolerated, can be contained later on in the life cycle. The project can, again, tolerate carrying this problem without resolving it right now. And then finally, oh, sorry, I haven't pressed. our final example here, up in the red, down in the red corner, if we really don't understand the problem, if we don't understand the problem space here, and we don't understand the range of solutions, the impact that might have, then it has potential to change the architecture of the system, affect other systems, or undermine the business case, then this is something that the project, we need to look at right now. This could, if we don't address this, gain better understanding now, it could undermine the project's success later. And we can use this style of thinking to look at how we mitigate problems using a combination or in isolation, different ways of moving a problem around on this matrix. So, for example, we can invest effort to understand a problem better. We can complete trade studies, we can explore the solutions to the point where we understand what the conflicts are, we understand what the options are, and we either select an option or are happy that we can live with that selection coming later. Or we can design our system to contain the impact better. So we can make it more modular, we can make the system configurable. So maybe this is not the right time to get the understanding of this part of the system, the way the HMI is going to work, the user experience in this area, and so we make that a configurable part of the system or modularized so that it's easy to change later. And finally, a project can just accept that this is not a problem that needs to be solved right now. For example, the kind of problem that is better, more efficiently solved by a more detailed design team when they will have more information available to them, and the problem space may be more constrained for their part of the solution. So we also considered what kind of characteristics push a problem into the red corner. I'm going to talk about the top two on this list, but not so much the bottom two, because I think they're self-evidently different ways of thinking about the impact. But the top two are a little bit more subtle. So top of my list is how well we understand the problem. Whether we understand there is a problem at all. It's easy for projects to have like blind spots that either just nobody's interested in or people are skirting because they know they don't understand. Or a group of stakeholders don't understand. And it's easy for projects to ignore those areas because they're not easy to show like measurable progress in. You can invest effort to understand the problem without really showing that you've got measurable progress towards your target. But they're dangerous too, because this is the area where hidden problems lie that could emerge later in the project life cycle that are going to be a real problem. You didn't understand this stakeholder, you didn't understand this baseline or emergent need, and so when you do come to understand it, you're stuck in that kind of yellow example of struggling to get back on track. And then the second line down, is there any solution? So again, like probably referring back a little bit back to the previous talk, there's some problems are easier to solve than others. If stakeholders they want different things from a system, they have like fundamentally different outcomes in mind, they want to achieve different values in the world, it is going to be harder to find a solution. And it's going to involve negotiation, compromise, it may involve changing the system boundary, or changing the architecture of the system, or splitting your system. And that's very different than the other end of the scale, where stakeholders, people involved in this debate, conversation, have the same outcomes in mind. They have the same needs. They want to achieve the same thing in the real world, but they have very different ideas about how to do this, whether that's in solution or way of working. Those conflicts can be just as ferocious and just as attention-grabbing, but once you've managed to tease out the separation between the problem, the need, and the solution, how you're going to do it, it opens up that range of different solutions to satisfy the needs of both stakeholders without compromise. And then finally, something that's not so much about the problem space, but about how we come to problems and how other people involved come to problems, and that is, what are we trying to achieve? So I think we all would like to think that what we're all trying to achieve is an improved outcome for the project, a system that works in the real world and delivers really wanted value. But there are always other things at play too that it helps to be aware of and helps to manage and understand. For example, we may be drawn towards funky, novel, exciting, complex technology, when actually a well-established, simple technology fits better with the user needs and the project's business case. and we should adopt that.
So if we look at the next tension that Kate introduced earlier, so this idea of a right first time approach versus more of a fail fast and learn approach that we can adopt. And again, we have a tension here, we have a tug of war between two opposing forces and two opposing potentially ideologies, if you want to call it that. Getting it right first time, I mean, that has a powerful allure about it. I mean, I've read and even written those words in many proposals and project plans and things over the years. And you know, the theory is it's helping us get on to the next step with confidence based on what we know. We're building a system up with correct decisions, step by step. It's helping us to eliminate our waste. It's helping us to eliminate our risk as we progress through the project. The flip side, though, the issue is that we basically have no tolerance for getting things wrong. When something doesn't go according to plan in the project, we deem that as a failure of the project and it must be avoided. So it really causes us issues around what do we do that? How do we explore things that we don't necessarily understand very well? And that's where we need to put more of an effort and more focus on looking at fail fast and learn solutions. So these allowing us to move rapidly towards our next step to see what doesn't work as early as possible. What do we not understand? What doesn't work about a technology, about potentially solution elements, about behaviors that we didn't expect and we can see to the extent that they might impact the rest of the system. And we're doing this in a very conscious, open way so that we know what we're getting into, we know how far we need to go to explore what we're trying to achieve with this particular approach, and we're looking for those issues, we're looking for the problems in a very alert way such that whenever we do come across a problem, we can pivot back to a point of stability quickly and progress on a slightly different path to maybe something that will give us something more desirable. And the point is, I think it was one of the comments in the previous presentation as well. It's okay to be wrong. It's okay to look at things and for them to fail and learn from that. We need to see failure as a learning experience and build on that. And thinking a bit more about right first time, it can be quite counterproductive. We've found if you look at different parts of the life cycle, look at the early stages of the life cycle, we want to be casting a wide net as possible to consider and reject as many ideas and solution concepts as possible. We want to be discovering what doesn't work in our technology. We want to be discovering what we don't understand about our stakeholders, about their needs, about the real world we have to interact with, the interface we have to interact with. And we're going to be more effective of using our collective intelligence as a team if we're sharing new ideas, being receptive to adopting new ideas from within our team and beyond our team, from our stakeholders. And we want to be creating that open sense of trust, being open about what we do and don't understand, so everyone understands where we're coming from and what we know and don't know. And similarly, as we go on later in the life cycle as well, a right first time can still be a problem. It delays difficult decisions, and where we want to be discovering gaps, understanding what the uncertainties are, what the conflicts are, and we want to be understanding the root cause of issues that emerge as our solution matures, or behaviors that emerge that we don't yet understand. And we want to be able to respond to new information that comes from our stakeholders, from the world around us, from interfacing systems as they also mature. And so again, we can be most effective if we're in a position where we can make decisions more promptly because, again, we're looking for those issues, we're looking for those problems, those failures that we can pivot back from. We can communicate our maturity more accurately because we're more open about understanding what the alternatives are and how they compare, and therefore actually how mature is our system compared to what it could be. And we're altering our thinking to fit with new information that's coming in that might affect and negate some of our previous assumptions.
I think going to move on to the third of those tensions, which was the games we create. As systems engineering leaders, we create, to some extent, and we influence the culture in which engineers are working. So we set the scope, we set the visibility, the process. We design systems for measuring their work, and which translate into valuing their work. And again, here there's another tension, of course. So on the one hand, we want to create that well-oiled machine of productivity, which keeps the engineers well-informed, measures the right thing, measures their progress along a process, and doesn't continually try to solve the same problem. So we have defined and maturing processes. On the other hand, we want our systems engineers and our engineers in general to have that line of sight to the system working in the real world and the problem space. We want them to understand the goals and what it's like to use this system and have their eyes on that real world change and be aware when we're moving towards delivering value and meeting that goal and when we're not. And this isn't always the same thing as making progress along a well-defined process.
So a few ways we break down. So first of all, we tend to break our life cycle down into elements. We break them down into work packages, into supplier contracts, and each of those elements have their own goals and objectives that are set, and each have their own constraints, sort of the classic iron triangle of time, budget, and scope. But as each element progresses and schedules inevitably slip because humans are terrible as planning estimators and budgets creep up, the scope inevitably gets affected as well, and the quality of your output can be affected. And essentially, there's a knock-on effect, so that the next element, the next work package picking up from you that's going to the next stage is having to do more with less. It could be less time, it could be less budget, and it's almost certainly less input and information than they initially hoped or planned to have. And the point is, we need to be more aware of this. We need to build this into our planning more as well. We need to think about, if you're in the blue project team and you're receiving input from the pink project team, you need to be looking both upstream and downstream of what's coming into you and what are you feeding into. If you're looking at what's coming into you, we need to look at the work that they did, validate it. Even in some cases, you may need to plan redoing some of the work they did in order to confirm within your contract, within your team, that you're on the right path. You know you're at your true course, your true position in the project, and you know the work you're going to do is going to carry the project forward to its actual objective, to its ultimate objectives, rather than what was originally defined when statements of work and contracts were written how many years prior.
The other way we break work down is architecturally. So very often a team will be working in a system that is really a part of a system of systems. And it's quite hard to understand how the work that you're doing on that system affects the user's experience in the real world. And again, within that, we create a microclimate for our engineers to work really, really efficiently in. We define processes so they always know what the step is and they know where the limit of their responsibility and ownership lies. And we define systems of metrics that measure their progress along that process and incentivize them to become more and more efficient. We also, the team structures tend to follow the architectural principles as well of aiming for low degrees of coupling and high degrees of cohesiveness, which is great in architecture and great for productivity, but really limits how much communication there is between teams in systems, and so again acts to limit the team's ability to look beyond the system and understand how they're driving towards delivering value in the real world. So teams that are working in this environment are well able to deliver really slick progress against your process, and they're able to find ways to hone and become more and more productive against that process, and to really play the metrics game and deliver good, impressive measured progress for this system. But what's much harder for them to do is to look up and understand how they're contributing to value in the real world, and understand when they stop to move towards that. And more importantly, for me, I think that it limits their ability to understand when their impressive, detailed engineering analysis and modelling is really telling them something about the real world that we need to pay attention to. So, for example, an area of the system is becoming too complex for the user to be able to use in the time they have available for it. Or a part of the system is becoming more expensive than the customer really values it, and we want to revisit the business case for that area of the system.
So we talk about playing the game, and projects kind of are a game in many respects. There's rules to them, and there's winning strategies we can play. to try and complete our objectives within our work package. And often we'll start the game, we'll run towards our goal as quickly as we can, and focus on what we can do now. Let's avoid the problems lurking around the corner. Things we don't quite understand. Well, let's just keep going, and maybe they won't catch us. Hopefully, we'll delay change as much as we can, and keep within our boundaries, stay in our lane on our work package, and get to that point we can say with confidence that we've delivered a model, we've on time, to a standard, following a process, and we've played the game and done what we said we were going to do. And we've measured our progress against process, winning points by beating the curve.
But getting our head back into the real world, we want something different. So for our real world winning strategies, that is the strategies that will help us to deliver the goal, the value that is wanted in the real world, we need to prioritize particular problems. We need to worry about things that we don't understand, the stakeholders that we don't understand, areas where there's a conflict. And we need to be able to seek and solve problems, confront the scary problems, and recognize the need to change promptly and make difficult decisions promptly. And to do this, we need our engineers to be able to look beyond the boundaries of the part of the system that they're working on. And we need for them to be able to be distracted and be curious to explore the role of this system in the world, and, for example, what it will be like to use this system and understand the system from the user's perspective. And we need to enable this, to be able to reliably deliver a system which integrates and does the job required of it in the real world. So stepping back a little bit to looking at each of those three areas of tension, whether we focus on problems or what we can do now and tactically make progress, whether... Sorry, what's the second one?
Fail fast.
Sorry, it's yours.
Versus get it right.
Whether we strive to get it right first time or we adopt a fail fast approach, and whether we focus on defining processes that are very measurable and very productive, or we focus on making sure our engineers are able to have that line of sight to value in the real world, and always making sure that we're aligning to deliver that. In each case, there are tensions for a good reason. Projects need to be able to they need to be in that stable, steady, continuous space where everybody knows what they're doing and we're just following the process and we're just delivering measurable progress. That needs to be a normal state for a project. But we also need to balance that against the need to keep an eye on the goal, understand when it's changing, understand when we've got it wrong and we need to change, and make those adjustments efficiently and promptly. I've come to think of this as having two modes, a badger mode and an owl mode. At any point in life of a project, we'll be largely working at a particular horizon in the life cycle. And when we encounter a problem, so that could be like requirements, it could be looking at the solution space, it could be design or specification. And when we encounter a problem, our normal and natural response is to look for more information, look to solve this at this level. So it's route around at this level, find more information, do comparisons, maybe dig deeper into the life cycle, look at different refinement options to understand what might solve this. And that's great, but not all problems are solved like that. Sometimes we need to be more like the owl. We need to go back up and have a look at our system in context, understand the world around the system, who we're interfacing with, and whether the goal is still the same, whether the goal is still valid. And if we find that we need to change, we need to be very alert to that and make our disruption accurate so that we can realign the project with its goals, make the course adjustment and move on efficiently. So building on this idea that we have these different modes of behaviour in systems engineering, we've recognised that we have the continue mode and the disrupt mode. In continue, when we're being more like the badger, we're looking for either refining our approach or refining the solution. We're continuing, measuring and making small course corrections, small adjustments, refinements. We're always just moving forward. In something like typical, the check, adjust, plan, do cycle. So here, where we're checking, are we following the plan? Is the quality good enough? Could we be more efficient? These are all things that can be addressed by making small-scale refinements and evolving the way that we're approaching the problem. But we also can imagine a disruptor loop to enable a project to understand when it's actually more efficient to be a bit more disruptive and make a bigger change. We need to be checking, as well as those like, are we on plan? Is the quality right? Are our project goals still valid in the world? Have they changed? Has the world changed around us? Are we moving towards the goals? Have we correctly understood them? Or has our understanding changed and we need to adjust to that? And do we understand how our system's going to integrate and work in the real world? And when we find this check is telling us, actually, no, this is not positive, we need to change something, we need to step back to explore, be the owl, look at the new information, understand it in the round, and understand what we need to do to disrupt what needs to change. And then make the disruption accurately and efficiently, because disruption is not a nice place to be. It's not where a project wants to spend a long amount of time, but it does need to happen efficiently and promptly. And then importantly, once we have disrupted, we need to restabilize to get the project back into the continue mode, because we said a project can't make progress just constantly and disrupt. You'll lose your engineering team because it's a stressful place to be.
So to kind of summarize all of this and how we can all play our part in it, and do more. So the first thing is we're not advocating that disruption engineering should be considered something like a methodology or a process. More process is not the answer here that we're looking for. Instead, trying to come up with a range of ideas that we can apply and in each of our roles and apply at individual levels, at team management and team culture levels, and also at stakeholder engagement levels. And if we look at each of those levels in the context, what Kate was going through of those, the continuation mode and assess when you need to do assessment and then when you need to actually go into disruption, we can kind of think about, here's some things we should be doing as individuals to make sure we're heading towards our goals. So it's being curious beyond our immediate scope, beyond our craft and metrics, looking ahead of us, looking upstream and downstream of us on either side. It's making sure we're working towards those real world outcomes for the project. And it's paying attention to what we don't understand. And again, that's what we don't understand about our stakeholders, what we don't understand about the technology we might be dealing with, or some of our interfaces, or whatever that might be. When we want to actually do an assessment itself, it's recognizing that need for change. So again, if you need to know what your outcomes are, if you want to know if you need to change. And it's also considering what happens if we don't change? If we do nothing, where's it going to go? How bad is it going to be? And is this a smaller scale sort of adjustment change, like the left-hand continue loop, or is this something that actually needs more intervention in a disruption context? And when we do have to go into that disruption, as individuals, it's important that we know who's making the decisions here, who's within our organization, within the team, who are those decision makers that we need to bring with us. They need to be on board. It's understanding how this change, how this disruption could affect them. What's the impact on them of applying this disruption, because disruption does have an impact. And it's also, again, what happens if we don't make that change, that disruption? What's the impact of doing nothing, and comparing those? And obviously, if disruption is required, that would indicate that the impact of disruption is going to be less than the impact of not doing anything. Similarly, we can think of this in the context of team leadership and those building a team culture and what you can do in that context. So again, in sort of the continuation mode, the badger mode of progress of the project, keeping line of sight of those real world outcomes and make sure everyone in the team has line of sight of what those real world outcomes need to be, what the project needs to deliver ultimately. Assessing the validity of our goals and assumptions, including the implied assumptions that maybe aren't written down and the team maybe know and maybe they aren't clear on. And being quite open about, or being open about realistically measuring the distance to achieving those goals, to achieving our milestones, to achieving the end of our work package and delivering something to the maturity that we're supposed to be delivering it to that supports those wider objectives. And again, when we're doing the assessment of where the project is and if change is needed, it's allowing the engineers and team to actually discover problems, report back, this is something we don't understand, this is something that seems to be going wrong, this is something that we need to focus on to make sure we're going in the right direction. And using the collective team intelligence to understand what those problems are telling us and communicate openly about the impacts of those and what we need to be doing about it. And then if we do apply disruption, it's collaboratively planning on targeted disruption. So we're focusing on what we need to change. We're not trying to be more disruptive than we have to be, because disruptive takes time and effort, and it's in the name, disruptive. So we want to be as targeted and efficient with that as possible. We want to understand how it's going to affect the wider team. So the work the team's doing now, the work the team's already done, what's invalidated potentially by this or not, the work that's already planned for the team coming up, how does that maybe change? And then, as we're saying, this plan of returning to stability. We can't stay in disruption. We need to restabilize the project as quickly as we can on its corrected course. And then lastly, this idea of applying this to wider stakeholder engagement as well. So when we're in that continuation mode, it's all about staying connected with all of the stakeholders, not just the loudest or the biggest or the ones with the most money, but all of our stakeholders need to be, we need to stay in touch with. We need to make sure we're understanding them and they're understanding us. We're using common language, and there's no misunderstandings about their needs or about what we're delivering with them. When we're assessing where the project's actually at, it's, from a stakeholder perspective, it's paying attention to those gaps, those tensions, any outstanding vagueness between what they're saying and what we understand, and vice versa. Another theme that was from the earlier presentation, it's that focusing on differentiating need from solution. So focusing on what we need to do, not how we're going to do it. There's more than one way to do things. And it's prioritizing those stakeholder issues. And finally, when we are applying disruption, disruption can be particularly alarming for external stakeholders. What's going on? What are you doing? So we need to be really open and honest about, this is what we do and don't know. This is why we're applying this disruption. This is the reasons behind it. Make sure stakeholders are on board with what you're trying to do, and collectively with them apply the disruption in as efficient way as possible, gain their support, get their collaboration on that, and again, restabilize that project on the new course as quickly as you can. And these are all points for just the starting point, really, for the conversation. It's a set of ideas. It's something to build on and think about. These things aren't. A lot of these things aren't new. There's a lot of kind of quite obvious things in here, but our view is we need to empower teams and individuals at all levels, individuals, teams, and stakeholders, to take part in this more. In order to legitimize applying disruption where it's required. It should be considered not a specialism, but a generalism. We need to be more owl sometimes in our view of where a project's going and where we're at. Because our view is short-term intervention can deliver that longer-term success and help ensure that the projects meet their target value.
So thank you for your attention. I'll just briefly summarise and then go to the questions. So we're proposing that disruption has a place in systems engineering if we use it at the right time in the right way. There are 3 tensions that we've identified that we think get in the way. I can definitely remember them, but I'm not going to list them here for time's sake. We've given you ways of thinking about problems so that we can prioritise the problems that really matter and not fall into that trap of, you need to solve all problems before the project can move on, and so contributing to the issue. And we've proposed a way to think about those team cultures that we're creating so that we're avoiding that kind of gamification of engineering for the short-term gain, but ignoring the strategic goal, and a way to envisage a separate disruption loop and return to stability, which I think we, again, stress is an important aspect of disruption, is that restabilization. Thank you for your attention, and on the spirit of that, I'd like to hear your thoughts and questions.
Okay, Neil, thank you for that. I really like the Badger Owl graphic. If if you don't mind, I'd like to use that on my day job next week.
Yeah.
Yeah, thank you.
Colin Cunningham from the University of Edinburgh. I thought that was really excellent, and I think if you want to show how that is demonstrated in real life, I don't know if anybody's ever seen Mark Wiles' talks about Crossrail and how he came in and basically disrupted the whole thing. But it literally was, the teams were all in badger mode. It was led by the civil engineers, and their role was to dig the tunnels and build the buildings. And the project didn't understand that our view was this was a complex systems project, and the real problems were in the signalling and the electronics and all that stuff that the civil engineers didn't understand. Which, you know, that's why it went wrong. And it's all on the web. You can read it all. It's fantastic. And it's exactly the same as what you're saying.
Oh, cool. I'll check it out. I haven't read it.
Yeah, but it's, you know, every project, I think the non-system engineers are particularly prone to badgering, but you know, it's for the system engineers to you know, fight against that as much as we can, you know, recognizing when we need to go more OWL.
Bruce Elliott, University of Birmingham. All of that aligns with my 40-year experience of engineering projects, but I've never seen this distinction drawn so clearly. That's really useful. And you invited discussion. I have a suggestion, and I'd like your view on it. We can't solve all of this on our own. I think that when it comes to this decision about what problems to tackle in what order, our natural allies are the members of the Chartered Institute of Management Accountants, whose day job is supporting that sort of management distinction. And to add a little bit of meat to that, if with a little bit of help from someone detached and objective, like a management accountant, you can put monetary values to your white blobs on your red, amber and green map. They don't have to be exact, actually, because it is a bit of a game, but they have to be fair. And then you can plot, the project manager can plot at monthly project boards, not just earned value, but total risk being carried. And as you move your pieces, your blobs, you make them smaller or you move them, the graph of weighted risk goes down. And then you've got the basis for challenge and discussion. So project manager, you've made excellent progress, but we're still carrying an awful lot of risk. Do you think it's time to turn your attention to that? Long question, sorry. What do you think?
And that's a great idea.
Yeah,
Yeah, because it would bring this into that kind of the project manager paradigm, and the project managers like what they begin to care about, isn't it? And I think one thing about that chart that I couldn't make clear is that as you go through the project, even whether it's like a notional or like an actual presented chart, the positions of those problems change, and new ones will bubble up to become the front runners for this stage of the project, the next thing that you need to focus on, and that would really support that.
Okay, thank you.
Thank you for your questions. Thank you for your answers. Thank
Okay.
you.
Thank you very much.